by way of introduction, we're going to be talking about quadratic equations, what they look like, standard form, and when we talk about solutions, what else we can say. Then we're going to walk through each of the methods, or at least provide you a space to show your work on how to solve by graphing. So you're going to put one equation here, solve it by graphing. We're going to do the same thing for solving by taking the square root. We're going to solve by completing the square. We're going to take one of these equations. We're going to put it here. Same thing with quadratic formula. One of these equations here is going to go right there. We're going to solve that way. And lastly, we've got three factoring that we're going to do. And as you can see down below, there's also one application down here. So, join me in the center star. This is a 5-pointed star because there are 5 methods that we talked about. We're going to each point of the star points to one of the methods to do this. So notice here, the first thing, solving. Of course, solving means get the value of x by itself. That's why I put the x equals blank in there. Quadratic means you have to have a square. Equation, got to have an equal to. So first off, what is standard form? What is standard form? Well, standard form looks like this, where we say ax squared plus bx plus c is equal to 0. Now, in one of your previous notes, we actually talked about all the 3 other synonyms, or very similar, very close to synonyms, for the word solution. For example, if they say, solve this quadratic, they could also say it in a couple different ways. So one of them starts with an R, one of them starts with a Y, and one of them starts with a Z. So the first one is called roots. And it might be called like the roots of the equation, or sometimes the roots of the function. I think the roots of the equation. Why? Because we're taking the square root-ish. Not entirely, but that's kind of what we're doing. So roots, R for roots. Roots. Then let's see, Y. Y-intercept of the function. The y-intercept of the function. In other words, when we graph it, where it crosses the x-axis. Oh, did I say x? Erase that, please. I made a mistake here. Change that y-intercept to x-intercept. I don't know what I was. X-intercept, because it's the x-intercepts. My apologies for confusing you. There we go, x-intercept. Y-intercept is important, but it's not part of the solution. Last thing, zeros. By the way, you can have an O-E-S or O-S, depending on, it's actually both are grammatically correct. Zeros, also called zeros of the function. So, 4 different ways the SAT, the MCAS, or some other test might try to confuse you. They might say, solve for x, or what are the solutions? Or they might say, what are the roots to the equation? Or they might say, if this were a function, what are the x-intercepts? Or they might say, what are the zeros of the function? Just different ways of saying solve for this. Okay, the next thing we're going to do is address each one of the stars that you see on the outside, pretty much the perimeter here. What we're going to do is try to figure out and tell you when the best way to use each method is. When do we use them? When is it going to be easy to use completing the square? So, let's start way over here with graphing. When can we use graphing? And the answer is anytime. However, I do want to put a caveat here, is if we're using technology, we have to estimate solutions. We have to, well, no matter what, we have to estimate the solutions. We don't always know exactly what the solution is. So we can use this anytime. We can always just plug something into Desmos and tap the x-intercepts and find the solutions. The major downside is that you're estimating. Usually the estimate is good enough, but that is a downside because it doesn't tell you the exact answer. All right, join me to the top middle. And when do we take the square root? When do we take the square root? Just for example, you don't have to write this down. But if I had something like this, right? X squared equals 36, right? I can solve by taking the square root of both sides. So the question is, when can I do that and when can I not? So it's best when this is true. Whenever b is 0. What do I mean by that? Look down here again. Whenever this guy right here is 0. In other words, there is no x term. It's just ax squared, and then it jumps to the constant, equals 0. So let's look over here real quick. Since what we're going to be doing is placing each one of these equations, each one of these is going to go in each one of these boxes here. So let's see. Let's look at this list here. Which one here of all of these has a value where b is 0? Nice. Take a gander at the very top one right here. The top one, the b is 0. So I'm going to take that 3x squared minus 75 equals 0, and I'm going to place it in the square root box here. This was a small mistake. Technically, I should have put this box up here so that you can show work under, but it is what it is right now. So 3x squared minus 75 equals 0. Because b is 0, this is a great method to use. Because b is 0, this is a great method to use. All right. Well, what happens when b is not 0? Well, that's what the other methods come into play here. So completing the square. When is it easiest or best to use completing the square? So the formatting on this star is a little bit messed up. This little space should be up there. But that's fine. It's best when this is the case. When a is 1, then I don't have to divide by a. And when b is even. Why? Remember, one of the steps on completing the square, and you don't have to write this down, is we have to find that missing term, where we take b, then we divide it by 2, and we square it. Notice an even number divided by 2 is going to give you an integer. So that's much better if b is even right there. So let's pause and look over my list there. Let's go back over to the list and see, completing the square. When is a1 and b even? So come down here, look for the a is 1, and find the b that's even. Notice this one right here. X squared plus 2x, so a is 1, b is even. So that's a great one. This one right here, I'm going to place in the completing the square box. So go ahead and write that in with me. X squared plus 2x minus 13 equals 0. Just like so. All right, let's turn our attention to the bottom left corner for factoring. And I'm going to be entering into this star. When is it best to use factoring? Under 2 conditions. The first part is we're going to use when there's a GCF. Whenever there's a greatest common factor that I can factor out, if I can pull out a number and or a letter, divide each term by it, there you go. GCF, I can solve by factoring, possibly. The other component is when the factors of AC sum to B. What do you mean by that? What do you mean by that? Well, remember Snowflake. That's what I mean by that. If Snowflake works, then you can solve this one by factoring. All right, now let's fly all the way over to quadratic formula. And when can we use quadratic formula? And this right here is the one formula to rule them all, and in the darkness bind them. We can use this one anytime, any place, anyhow. We can use it with positives and negatives. We can use it when A is 1, when A is not 1. We can use it when we have large numbers or small numbers or decimals. Doesn't matter. We'll get exact answers, and we can get approximate answers. So quadratic formula is the one that will always, always work. All right. So that brings us to a few other components here. I do want to point out and discuss real quick in your 4-7 notes, we talked about something called the discriminant. Discriminant means it helps to differentiate what types of answers we're going to get or types of solutions. So the discriminant says if we're going to have 2 real solutions, 1 real solution, or no real solutions. So if you don't remember, and I'm in the quadratic formula box here, the discriminant looks like this. It's the part of the quadratic formula that's inside the square root, the b squared minus 4ac. So that's my discriminant. So just as a refreshment, whenever d is equal to a positive, or d is greater than 0, in other words, it's positive, if d is positive, you're going to have 2 real solutions. Whenever d is equal to 0, which is still fine because I can take the square root of 0, that's fine, then we get 1 real solution. And whenever d is less than 0, in other words, a negative number, it's down here, and at this stage, we can't solve it. So we say no real solutions. After spring break, we'll look at that not only can we find out that they are no real solutions, we're going to find out what those fake solutions are. We call them imaginary numbers. So let's think about what that looks like as a graph. So join me. Caddy corner, we're looking at the graphing and number of real solutions. Your sketch can look anything at all like you want as long as it crosses the x-axis twice, like this. Okay, it doesn't matter where your parabola crosses, but notice here, we have 2 solutions. We have 2 real solutions because the parabola crosses the x-axis twice. You could have a parabola opening upward, so flip this one upside down. As long as it crosses the x-axis twice, you've got 2 real solutions. For 1 real solution, you might have a situation like this where you have a dangling, like the parabola is dangling off the edge there. Because that's it right there. That's my 1 solution. Or you could have it just resting like this. It could just be resting like this. And this here is my solution. Just on the x-axis. These are 2 separate scenarios. So let's see here. This parabola crosses the x-axis twice. These parabolas just cross the x-axis or intercept. They only have 1 x-intercept. So how do I make it so I have no x-intercepts? Oh, well, that's kind of just floating, right? Like here we go, floating. No x-intercepts. There are no x-intercepts, therefore there are no solutions to the equation. So these are the scenarios for the number of solutions. And also we talked about the best case scenarios and when to use each of these. So here's what you're responsible for now. You're responsible for taking each of the remaining 5 equations and you're going to place them in each of the remaining 5 equation territories. Now, let me give you a hint first. Don't just throw anything anywhere. I suggest figuring out which ones can be factored, which one has a GCF, which one can be snowflaked and snowflaked when A is 1 and when A is not 1. And then the remaining 2 you can put up in the graphing and the quadratic. So get these 3 figured out first, and then we can place the other 2 right there. So the second thing that we're doing is that you're going to actually solve these. Notice what the instructions say. Place each equation in an appropriate box. So we've done that for 2. And we're going to solve accordingly. So this one will solve by completing the square. We're going to write the solutions in radical form, the exact answer. And we're going to round the solutions as well using a calculator. Then we're going to write the steps as you solve. So here's a key thing here. Write the steps as you solve. You might find that this is where your handwriting might be bigger and might not fit everything in the box. So either use your eraser or do the math and then the explanation under, like this. Or if you write small enough, do the math here and the explanation there, right? This is what I'm going to do. Math there, explanation there. But if your handwriting doesn't fit, that's fine. Just do all the math there and explanation under, like this. Oh, but Swenson, what if it still doesn't fit? Because I need more space. Like I said earlier, see back. Oh, but I don't like that. That means I have to move stuff around. Okay, that's fine. Do the whole thing in the back then. Or the whole thing on a separate sheet of paper. That's fine. Okay? By the way, this project-y thing is worth a quiz. So I expect it to look very nice and very presentable. So let's walk through the completing the square one together so that you know what my expectations are for all the other boxes. I won't do this entire thing, but I will set it up and get us going. So for this one, completing the square. Remember, our first major step is to get the constant by itself. So I do this. X squared plus 2x, don't forget to leave a space, 13. And on the side, I'm going to explain what I did. Isolate constant. Now, it turns out there's also something else I need to do at this stage. I have to add that super secret missing term. So let's think about it. What's the missing term here? I have to take the positive 2 here, divide it by 2, and then square it. 2 divided by 2 is 1. When I square that, I get a 1. So add 1 to both sides. Let me explain that over here. Add missing term. Again, if your handwriting is such that you don't have enough room, then put the words under, or do this on a separate sheet of paper or on the back. But again, the key is keep yourself organized and make sure you're using words when you explain. Now, I'm not going to do all of this, but I will walk through a few more steps, or at least partial steps. Notice that this left side here will always become a perfect square. And let me explain what I did there. We write as perfect square. There's my steps. Now, the next step is I'm going to take the square root. Take the square root. So whatever this simplifies to, and that's inside here, that's going to be on this side equals plus or minus the square root of 14. Now, I'm not going to do all this for you. I'll let you keep working on this. But again, my expectation is that you do the math here, explain over here. If there's not room and you can't stack it, then just do so on a separate sheet of paper. Yeah, there we go. So this everything here will be filled in. I suggest before you start solving, just make sure these are all placed in the appropriate boxes. All right, so I'll pause there.